What if I told you there's a tiny chemical fireplace hiding in your lunch? No flame, no battery, no microwave. Add a splash of water, and suddenly the whole container turns into a pocket-sized heater. It's not magic. It's chemistry you can literally feel through the packaging. Welcome back to the Smart Side, where we skip the boring stuff and see how the world really works. Today, we're unpacking the science inside self-heating meals, why they get so intense, how they stay under control, and how they warm your food fast, without, burning the house down. Alright, picture this. You're holding a self-heating pouch. Inside, the food, and a little heating pad right beside it. You pour in a bit of water, seal the top, and the temperature starts to climb. At first, it's a gentle warmth. Then it's, wow. And then, wait, how is this getting so hot? So, where is that energy coming from? It's not electricity. And there's definitely no hidden flame. It's an exothermic reaction. Here's the idea, in plain English. Some reactions need energy to get going, but others release energy. Because the after version of the molecules is more stable or calmer than the before version. That leftover energy has to go somewhere, so it pours out as heat. Self-heating meals do one job. They push ingredients to settle down into a stable form, then use that released energy to warm your dinner. So, what's the actual reaction? The most common method uses quicklime, also called calcium oxide. When calcium oxide touches water, it doesn't just get wet, it reacts, and it releases heat fast. The chemistry looks like this. Calcium oxide plus water becomes calcium hydroxide, plus a big burst of heat. Think of it like this. Calcium oxide starts in a high-energy, restless state. Add water, atoms rearrange into something more relaxed, and as they settle, they dump that extra energy into your food, and it feels intense. For two big reasons. First, they don't use a tiny pinch. It's a precisely measured charge, enough to heat about a pound of food. Second, the heater pack has huge surface area. When water hits, the reaction happens everywhere, almost at once. More contact, more reaction, more heat. Now, here's a detail most people miss. The food isn't just heated by touching the pack. It's heated by steam. Once the heater peaks, the extra water flashes into steam inside the pouch. Steam's an incredible heat carrier. It makes a tiny, high-pressure sauna that wraps around your food. That's why these meals warm so evenly, instead of scorching one side. And quicklime isn't the only player. Some higher-end heaters use metal-based reactions, usually magnesium or iron. Different chemistry, same idea. Ingredients rearrange. Energy is released, and the package channels it straight into your meal. And that's why the labels sound so serious. Use a ventilated area and never tear open the heater pouch. The materials inside are meant to be reactive, definitely not for skin contact. So if these reactions get so hot, how does the bag not melt? This is where the engineering gets clever. Self-heating meals are controlled chemistry. Control method 1, water volume. Water doesn't just start the fire, it limits it. Too little, the reaction stalls. The right amount gives a predictable, safe rise in temperature. Control method 2, the pouch membrane. The heater controls how water seeps through, so instead of one big burst, you get a smooth, steady climb. Control method 3, spacing. The heater sits close to transfer energy, while the packaging acts like a thermal barrier. Heat stays in, chemicals stay out. Here's the key. The goal isn't the highest temperature. The goal is the perfect heat curve. Quick warm-up, a steady soak to heat the core, then a slow cool down so you don't burn your tongue. A great self-heating meal doesn't just get hot. it gets hot the right way. So, the secret's out. A heat-releasing reaction triggered by water, shaped by smart packaging, and carried by steam. Next time you pull that tab and hear the hiss, you'll know exactly what's happening. You're not just eating, you're operating a tiny, portable chemistry lab. Fast, convenient, and surprisingly brilliant. One last safety note. Those heater packs stay hot long after you're done. Follow the instructions, let it cool completely, and never touch the contents. If you learned something today, tap like and subscribe. It really helps the smart side reach more curious minds like yours.